We now know that the whole world is made of incredibly tiny particles called atoms. 1 million atoms will fit across the width of a hair. The word atom comes from the Greek word meaning uncuttable or indivisible. We can easily cut a strand of hair again and again and again. But eventually, if our scissors are small and sharp enough, we would cut down to a single atom inside the hair, and we could not cut that. This means that an atom is the basic building block of the hair, and that's true for all stuff in the universe too. Although scientists prefer to call stuff matter. So then, an atom is the basic building block of matter. Huge mountains are made of atoms. People, things people make, like cameras, even air is made of atoms. Now, a fair question to ask is, are all atoms the same? Well, the answer turns out to be no. Scientists have discovered 92 different kinds of atoms in our world. In fact, when they look into outer space, they find the same 92 kinds of atoms in the whole universe. Now that's incredible. Back on Earth, there's lots of oxygen, silicon, aluminium and iron, and smaller amounts of other types of atoms too. But it's rare to find a substance made of just one kind of atom all on its own. Normally, different types of atoms are mixed in with each other somehow, like oxygen and nitrogen in air. But when we do, we call that substance an element. A substance made of only one kind of atom is called an element. Air is not an element, but a nugget of gold is. It's made of only gold atoms. So what's this element gold like? Checking it out, we find that it is yellow, shiny, soft, solid and dense, which means heavy for its size. If we had the same space filled with water, gold would be 20 times heavier. If we hammered it, we could flatten it out into such a thin sheet that a piece of gold the size of an M&M would cover your classroom floor. This is called being malleable, and gold is the most malleable element of all. Another test would show that it conducts electricity really well, and if you heated it, it would melt at 1064 degrees Celsius. These things about gold that we can observe or measure are called its properties. They are unique to gold. Let's look at an element made of carbon atoms instead. Because carbon and gold atoms are different, we expect carbon and gold elements to be different too. You don't have to go far to find a piece of pure carbon. If you have a lead pencil on your desk right now, you really do have about 100,000 billion carbon atoms in the lead. The lead isn't lead at all, but carbon. It should be called a carbon pencil. Up close we can see that carbon is black, or blackish, shiny, hard, solid, and it's got medium density. That is, it only weighs about twice the same space full of water compared to that of gold's 20 times. Hitting it with a hammer will smash it into bits, which means it's brittle, the opposite of malleable. Rubbing it on your finger will show it's slippery, or leaves thin layers of itself behind on your skin, pencil marks. It conducts electricity, but not as well as gold or other metals. If you heat it, it vaporizes at 3642 degrees Celsius. You can see that carbon's properties are different to gold's. They are both shiny and solid, but overall they are very different. It's as though each has its own personality, its own unique set of properties. And this is linked to the uniqueness of the tiny atoms that make it up. We can't see carbon's billions of atoms with our own eyes. They're much too small. But we can with the strange-sounding electron tunneling microscope. By zooming in 1 billion times, we can eventually see a single carbon atom. You can see they're a bit fuzzy. All atoms are. Now let's back up, and we can see the whole bunch of carbon atoms, which together comprises the element carbon. We can use the word carbon to mean either a single atom of carbon or the element carbon made up of many carbon atoms. Both uses are correct. If we mean a single atom of carbon, we are speaking microscopically, that is, on the very small scale. If we mean the element carbon, that is, zillions of atoms of carbon, so many that we can see them, then we are speaking macroscopically, that is, on the large scale of the everyday world. We've seen that the properties of an element depend a lot on which kind of atom it's made from. So how are these kinds of atoms different to each other? Let's line up a few and see. Some types are small and light, like hydrogen, the lightest, and others are big and heavy, like uranium, the heaviest, and other types are in between. This just shows a handful of the 92 kinds of atoms that there are, starting from the first, hydrogen, through to the 92nd, uranium. Sixth in line is carbon, and chlorine is 17th. Gold is the 79th element, so you can see it's towards the heavy end of the list. An element's place in this list corresponds to its atomic number. For example, the first and lightest atom, hydrogen, has an atomic number of 1. Carbon's is 6, and uranium's is 92, and so on. The atomic number is also connected to the number of positively charged particles called protons, which live inside the atom. But we will come back to that in a later video. Each kind of atom has its own atomic number, and each atomic number belongs to just one kind of atom. Scientists sometimes shorten the name of a type of atom to just 1 or 2 letters. Hydrogen is shortened to H and carbon to C. Chlorine can't be C because C is already taken by carbon, so it's written Cl with a little l. Now you may think that the shorthand for gold would be G or Go, but you would be wrong. Instead, it is Au. That comes from the Latin aureum and refers to the word aura, meaning the glow of sunrise. No prizes for guessing the shorthand for uranium. It's just U. This shorthand way of writing is called the symbol of an element. Here are the names, symbols, and atomic numbers of the first 30 elements. I bet you've heard of some of them before. Check them out. We'll wrap up the video by going over the main points. We saw that the incredibly tiny atom is the basic building block of matter, and that an element is a substance made of only one kind of atom, and that a property is something about a substance that we can measure or observe, like colour, and that microscopic means the very small scale of atoms that are too tiny to see with our eyes, and that macroscopic means the normal scale of our everyday world that we can see with our eyes.